Hey everybody, I'm sorry that I can't be in class today. I'm unfortunately doing a 30-hour OSHA safety training course in Santa Ana, and I'll be doing it this weekend, and I'll do it again in a couple of weeks. So, very sorry that I can't be there in class today. But I thought I would go ahead and record a nice little video, and I'd like to go over the two-story house tutorial. I know a lot of us got a good head start on it in last class. I'm pretty proud of where everyone got to, but we got a little behind in certain steps. So I'm just going to record this video, and this will be the assignment that's due in the next week. And so go ahead and use this video to help you get the tutorial done. I've got my PDF open. I've got my binder here too, but I've got the two-story house PDF. Should be available there on Canvas. And let's go ahead and get started. So I'm going to go ahead and open up FrameCAD Structure. I'm going to go to Open Files, and I'm going to navigate to my folder that I have on my desktop in Porto. And you guys should all have your little folders on the desktop if you made that in the first few weeks of class. I'm going to navigate to the correct folder where these files are currently living in. And what I'm going to do is I'm going to choose the 1-4 IN 11 by 17 template. So as a reminder, this is our 1/4 inch template. And this 1/4 inch template is has a 11 by 17 inch sheet size. So when you are in layouts, that's the size of the paper that it's drawing everything at, and the scale of those drawings are 1/4 inch. And as a little reminder, you always want to start with one of these templates, because when we created these templates, we went through all the boring settings that we need to set up, and we saved it as a template, so that way we don't have to go through all that again each time we start a project. These templates serve as a great starting point, but you would have to adjust per project. Okay, so I'm going to start with a 1/4 inch 11 by 17. I'm going to hit open, and I am now here in layouts. First thing I want to do is I want to go up to structure, and I want to find my B set, which is under panels / walls. And oops, sorry, I'm in the wrong structure tab. It should be this structure tab. And you want to go to border setup or B set. And you could also type this in. Right? You can click here for border setup, but you can also type in B set as one word. So I'm going to do that. B set. Okay. So all these settings here were saved into the template that we've opened up, right? So what we're going to do now is adjust this template to create a brand new template. And we're going to save this file and give it a new name, because it'll be a new template that we can use in future projects. And then we'll save over it one more time to start this particular two-story project. Okay, so I've got BSet open. I'm going to go to sheet quantity. I want to make sure that it's at 6 for this particular project. We need more than 4. And row is still going to stay at 2. And I'm going to also go to, I'm going to hit OK, and I'm going to go to P set or panel settings. So type that in, P set. So these are our settings for panels. Some things I want to modify include in panel model settings division, Plaster stud 1 should say 3/4 inch. Plaster stud 2 should say 3/4 inch. Add service holes to top plate. We don't usually want service holes in our top plates. If we end up needing service holes in our top plate, we can add them on later on in Detailer. It would be easier to add in the few service holes that you want on your top plates versus removing every service hole from each panel later on. So we'll set that one to false. Make sure add truss holes to top plate is set to true. For brace panel information, we want brace type to say K brace and stud base or setup or strap angle set to 1. Let's go to the options tab now, and we want to look at panel builder filters, and for current view only, we're going to set this one to true. Oops, true. And go ahead and hit save. Now let's do our joist settings or floor settings. So for that, we want to type in JSet. So for JSet, we want to be really careful on this part. I think this might have been the part that messed up a lot of our files, a lot of your guys' work. So let's zoom into our PDF. I'm going to bring that over here. And what we want to do is we want to make sure that our settings are pretty close to this screenshot. And make sure that model name, joist type, all of these settings are changed. So I'm going to go ahead and scooch that back over and do it here live. So model name would be WJ36203350. So model name. Click this secret little drop down menu, and I'm going to do my best to find WJ36203350. Should be that one right there. And I want to make sure joist type, it's got the same model number, WJ362. 362 represents the 3 5/8 of our metal studs. 03350. WJ362-033-50. Our end bearer type. End bearer type should be same thing. WJ3650. WJ362-03350. And one more time. WJ362-033. WJ362-03350. Our member override height should be 11.5 inches. Okay. Our joist spacing should be 2 feet, 10 feet for the internal bearer spacing, 2 feet for the ceiling batten spacing. 8 foot 11.5 is our reduced height, so 8 foot 11.5 inch. And our bearer methods and internal bearer method, we want it to be blocking and blocking, and we want it to say true for the double interior bearers, and false for oncoming web align, and false for double webs to support. Layout colors 256, that's all good. And let's go ahead and save that. Let's go to T-set or truss settings. Whoops, T-set. Alright, so here, model name 362 LE system, roof load sheet. Roof pitch is going to be, since it's a 312 roof that we're creating, that angle is 14.0362. you can use this little secret ellipse button to figure out that specific angle. So in this dialog box here, if let's see, length or run. So if my length is 12 and my rise is 3, my pitch is 312, which is just a nominal ratio that we use in our vocabulary for roof pitch, but the specific angle is actually 14.0362. So what we can do now that we have that angle, we can just hit transfer and it'll update roof pitch and sub pitch. That's one way of doing it. You can also just type in that number if you calculated it off to the side on your phone or whatever. So we've got 14.0362 twice W110 is our wind speed. Let's go to reduce level. So reduce level, we want to set that one to 16 foot, 11.5 inches. Reason for that is that our reduced level for the first floor walls is 0. The reduced level for the floor of the second story, and hence our joists, are at 8 foot, 11.5 inches. And so the reduced level for our trusses, which create the roof structure, sit on top of 8 foot walls, 11.5 inch floor, and more 8 foot walls. So altogether, that's 16 foot, 11.5 inches. Okay. So got that. Our hip method should be half truss. Our OH method should be overhang frames, that one here. Our eave option is standard eave, and our heel height is 6 inches. Let's go ahead and put 6 there. And everything else looks alright. Bracing type. Okay, that looks good. So we'll hit save. Okay. Okay, so now what we want to do is we typically start our projects by drawing a building outline, our building footprint on each sheet. And what I want you guys to do is just do it once, just draw the building footprint once and copy it to each sheet. So first thing I'm going to do is type in V, enter. Excuse me. Now that I'm in FrameCAD structure, I'm going to type in V, hit enter, or space, or right click, and it says view name 1, and that's just going to snap me to view 1. Next thing I want to do is I just want to create a polyline. So you can type in PL for polyline, and what I want to do is draw a 21 foot. So I'm going to repeat that. I do polyline, and a polyline consists of points, so I need to define where those points are. I'm going to click, I'm going to left click here one time, and once I start hovering around the screen, it's constrained this polyline to that first click that I made, right? And now it's wondering, where are you going to put that next click? And when I want to click 21 feet. So I'm going to type in 21 feet, I'm going to hit enter, and I am going to do that. That's not right. Okay, and I'm going to do 16 feet and 21 feet. Oops, 21 feet and 16 feet. Alright, that looks a little big. Let's zoom in and see what our scale is. Uh-oh, whoops. Looks like I didn't change the scale for my B set, so that's because I totally skipped the very first 6 steps. Hey everybody, I'm sorry that I can't be there in class today, but I went ahead and recorded this video for you guys to play over and over again so we can have a 2-story house done in FrameCAD structure. The plan is that I'll go through the entire tutorial. You can slow it down, pause it at any moment that you want, and the goal will be for you to have your own 2-story house done in FrameCAD structure. So let's get started. I've pulled up the PDF. This is on Canvas. You're looking for the 2-story house PDF. So let's start right here. One of the first things that we want to do is we want to take an existing template that we have, and we already started to do this in class, but I'm gonna start all over because we had a little bit of a mess in our class last Thursday. So I'm going to start fresh. And so what we want to do is we want to open up our save template, right? So we had already made a 1-inch template. So you want to open that template up, and immediately you want to save over that template. So you're going to do a save as, and you're going to title it 1/4 inch by 1/4 inch 11 by 17. That'll be the name of that new template. Okay, and so once you save over it, you're gonna go through it while it's open, and you're gonna go through B set, J set, T set, P set, and you're gonna modify a lot of the settings for it, and by doing that, you'll have a brand new template to make this 2-story house, right? We need different settings in this structure file for a 2-story house than we would for a small tool shed that we've made in the past, right? So the scale of your project dictates some of these settings. So I'm going to go ahead and move this out of the way, push it off to the side, and I've got FrameCAD structure open here. I'm going to go ahead and click open, and I want you guys to navigate to the location to which your templates are. I've instructed you guys to create a folder with your name on it on your Oporto desktop. So while you're here in Oporto looking for a drawing to open, go to your desktop, find the folder that I had you make. This is mine right here, Jojo Crowley. Put a couple of exclamation points so I know that that's a folder that I made. And I want you to go to whichever folder that you put your template in, and we're going to open up the 1-inch template. And so when you're working in structure and you're working on a big project, you are always wanting to start with a template. You might end up with several templates at some point, but having these templates is always a great starting point, especially for repeatability. If you were to do a 2-story house or several 2-story houses, you might always want to use the template that we're about to make as a starting point. So 1-inch template is here. This is something we made back in February. First thing I'm going to do is I'm going to type in save as. And what we want to do is we want to call it 1/4 inch. And unfortunately, this is the best way to type it. Whoops. No, not that way. 1_4_IN _ wait, too many underscores. Well, one more underscore 11 by 17. And as you can see, I already have that file because I have it from last class. We all should already have that file. So go ahead and I'm going to go ahead and save right over that file that I made because I want to start fresh. I know a lot of us had issues going through this tutorial, so yeah, let's just start fresh. I'm going to click save, and it's going to ask me, hey, are you sure that you want to save it? You sure you want to call it this? You already have a file with that same exact name. If you name it this, it's going to replace the old one. So yeah, go ahead. Let's do it. Alright, so now we technically have a whole new brand new template. It's got the same settings as the 1-inch template because I haven't changed anything yet. And so next thing I want to do is go to B-set, and I want to change the scale of my drawings. This was set up in such a way that the scale is 1 inch is equal to a foot. Now what I want to do is use a 1/4 inch is equal to a foot. So let me find out where I do that. Oh, sheet options. So border scale, right? Border is talking about the title block there. The scale of that border is currently set to 1 inch is equal to a foot. And I do not want that because it's going to create a really humongous, ugly drawing that won't fit on my sheets. So I'm going to actually call it 1/4 inch is equal to a foot. And as far as quantity goes, I think I want to go with 6 sheets laid out in 2 rows. Okay. And I'm going to hit OK. So now, this is my new template. This is my new 17 by 11, and I can zoom in and see it's a 17 by 11. It's a 1/4 inch is equal to a foot. Actually, it says letter on it here. Let's see, do I want letter or do I want 11 by 17? Looks like I want 11 by 17. So I'm going to go ahead and do B-set. And I'm going to go to sheet options and change this to 17 by 11. There we go. Yeah, sorry about that. Alright, now it's refreshed with 6 brand new tabloid size digital pieces of paper at 1/4 inch, right? So the scale of it and the paper size correlate with the name that I gave this file. So that's good. I'm going to type in save, and that's going to lock this in as my new template. Sure, override it. So now I have a whole new template, and you guys always want to start with a template when you make a project. Otherwise, you got to go through all the B set, all the P set, all the J set, and all the T set. All those settings you're going to have to start over with unless you use a template. So I've got a new template now, and what I'm going to do is I'm going to do a save as again. So let's go save as. And this time what I want to do is I don't need to create a whole nother template. What I'm actually going to do instead is give it a title appropriate to the project. And so this is the 2-story house tutorial. I'm going to call it 2-story house. And just like last time with the last template, we already have a 2-story house file. And I'm okay with replacing it because I want to start fresh. If you want to not touch this 2-story house that you were working on last Thursday, give this a unique name. Okay, call it 2-story house number 2, or give it a funny name, 2-story house, the return of the 2-story house or something. I'm just going to leave it as 2-story house. I'm going to click save. It's going to ask me if I want to replace the old one. I'm totally fine with that. Okay, so notice up here in this tab, it no longer says 1/4 inch is equal to a foot template, blah, blah, blah. Now it says 2-story house. So now I can actually get started with this file, this project. So what I want to do is type in VSet, and I want to change the I already did the quantity sheets. I want to actually go ahead and skip to PSet now. So I'm going to go to PSet. Might have done that out of order. PSet. So the important thing here for PSet is plaster stud 1 3/4 inch, plaster stud 2 3/4 inch, add service holes to top plate. Add service holes to top plate, that should be false. It would be a little bit easier if we say that this is false, and then draw in surface holes as needed in Detailer, versus having structure automatically populate surface holes in our top plates, and then going to Detailer and removing them all, right? Because we probably don't need that many surface holes on our top plates, if any at all. So that's set to false. Add truss holes to top plate. We'll keep that at true. Brace panel information. Right here, K-brace, stud bay, or strap angle set to 1. Perfect. Okay, let's go to options. Let's go ahead and expand panel builder filters, and the one we want to mess with is called current view only, and we want to set that to true. And let's hit save. Okay, great. And I always recommend that you guys save your files as you go along. Alright, next one is JSet. So you can access that by typing in JSet, or you can even go and under this structure tab and click here under floor settings. Floor settings and JSet are the same because floors structurally are made out of joists, hence JSet, hence joist settings. So go ahead and click on that. And what we want to do here is change model name, joist type, side bearer type, end bearer type, interior bearer type to say WJ362033350. So model name is WJ362033350. This one's already correct. This one's already correct. Let's do end bearer type 36203350. Interior bearer type, same. WJ362033350. 362033350. And member height override. So we want to actually go with an 11.5 inch member height override. Whoops, that says 5.5 inches. 11.5 inches. And that represents a 12-inch nominal joist. Okay. The reduced level is this one right here. The reduced level is the height of the floor system and is measured to the top chord of the joists. So what that means is the top of our floor is the height that they're looking for reduced level. So if we think about it, we have 8-foot walls that are sitting on some sort of foundation. I think this template's set for a slab foundation, but our 8-foot FrameCAD walls will be sitting on top of the foundation, and these 11.5 inch joists will be sitting on top of that. So therefore, the top of the structure of the floor sits at a reduced level of 8 foot 11 and a half. So I'm going to change 0 inches to 8 foot dash 11 dash 1/2 quotation marks 8 foot 11 and a half. Okay, and let's hit save. Next thing we want to do is our truss settings, or T-set. So for T-set, we want to change this model name. That is not the correct model name. We actually have a 362LE system. Roof load is set to sheet. Roof pitch is 14.036. Why 14.036? Well, if you click this little ellipse here, this is an angle calculation that's already built into FrameCAD structure. It's kind of clever. So the way this thing works is typically we understand roof pitches using a ratio of rise and run, and we always use 12 inches as part of that ratio. So if our run is 12 inches and we want to do a 312 pitch roof, our height or rise is 3 inches. Okay, so 3 inches up, 12 inches over. 3 inches up, 12 inches over. That creates a slope that is what we call 312. So if I type in 12, and since it already says 3, I'm going to type in something different. So let's say I want to know what a 212 pitch is. It shows you in this little diagram that if you have a 12-inch run, 2-inch rise, the roof pitch of 212, the angle is actually 9.462. And it's got it right here for you. So what you could do with this information is just hit transfer, and it will actually transfer those numbers and that data right here under roof pitch and sub pitch. So I'm going to make sure to change this because we are actually working with a 312 in this tutorial. So instead of 2, I'm going to hit 12. It's already calculated that for me, and I can hit transfer, and that's how I get my 14.0362. You can also do this calculation on your own if you're confident enough, but you just type in that angle right there, and that's where you do it. Okay, so the next thing I want to do is go to reduce level. So again, with my reduce level, these are my trusses. All right, this is T-set. So the reduced level, if we visualize it in our heads, right, is we have foundation. Our top of foundation is at 0. Our 8-foot walls sit above that. So now we're at 8 feet. Our joists for the floor have a height of 11.5 inches. This is a 2-story house, so there will be 8-foot walls above that. And that's the reduced level in this situation. So in this case, because we're dealing with trusses, the level is taken from the bottom chord of the truss, right? The bottom chord of this truss. So if we have 8-foot walls, 11.5 inch floor, 8-foot walls, that gets us at 16 foot 11.5 inches. And that's the bottom of our trusses, right? Because the top of our trusses could actually vary depending on the type of roof that we want to use, and it's got to account for the roof pitch. So we can't really measure the reduced level by the top chord as we did with the floor. What we actually want to do is measure to the bottom chord. So 16 foot 11.5 inches. I hope I typed that correctly. Alright. Hit method, half truss. OH method, overhang frames. Standard eave, 6-inch heel height. Okay. Alright. That's it. Great. So now let's go ahead and we're going to begin by creating the outline and reference points. So I like to start off by working in a very specific view. So if you type in V and hit enter or space or right click, and it's asking you what view I want to go to, I'm going to say 1, and now it's zoomed me right into view 1. So to make that building footprint, we need to create a polyline. So I'm going to type in PL, and I'm going to draw my building footprint here. The way it works is you must click on the screen, and I'm going to do that now. I'm going to left click, boom, and as I hover my mouse around on the screen, you know, it's doing this weird thing where this thing is kind of following me around. What I want to do is I want to define the shape of this rectangle by saying 21 feet and hitting enter. And as you can see, what it did here is, whoops, what it did here is it made that 21-foot line, but now, you know, because it's a polyline command, it's like, where's the next line going? Let's make some more lines. So what you actually want to do is you want to make sure you hover downwards, so that way your line is starting to go down, and then you're going to type in 16 feet. Enter. Now, nothing happened, so I'm going to try that again. 16 feet, enter. Okay, there we go. So now, you know, it still wants me to keep going, and I need to keep going anyway, so I'm going to say 21 feet, and now I'm going to close it up by saying 16 feet, enter, and it wants to keep going, but I'm all done, so I'm going to go ahead and hit enter, and I'm pretty satisfied with that. The next thing I want to do is, typically we want to try to center this as best as possible. So one strategy would be to, let's hit escape first. Here under entity snaps, I would make sure to have perpendicular snap on. That's always a good one. Let's see, I want to do my midpoint one. That one's always the best one. Set midpoint snap. Okay, so now what we want to do is, if I highlight that using a cross selection window, type in M for move, and click here, right? I'm going to hover over it first. I'm going to let this CAD software figure out where the midpoint is, and I'm pretty sure I know where it is, but it understands exactly where it is, so I'm going to click that. So I just clicked it. And what I want to do now is I want to find, let's see if I can find the midpoint of, oh, that's so cool. I'm going to put this way over here. Oh, I see, this is in Porto. Okay, so let's put it, so what you can do is you can actually find the midpoint of this sheet, or as they call it in FrameCAD structure, there's a border. So I'm going to match the midpoints. I'm going to move this rectangle from the midpoint of that top line to the midpoint of the border. Okay, so now it's vertically aligned, and the next thing I want to do is, just to be technical and have it perfectly centered, I'm going to type in PL, hit enter, and if I just draw a line from, let's say, from here to right there, hit enter, okay, type in PL again, and I'm going to hover over here to find the midpoint of this line. I'm going to just go ahead and click, put it right there, and hit enter. And now I can take this whole thing, I can move it, and move it from this midpoint and to that perpendicular point to it, and boom, there you go. And now just take these two, boom, delete it. Now this rectangle is perfectly centered. It's completely unnecessary to perfectly center this in your border, but it is important to center it somewhere within that border so that way you can have the flexibility to draw around it. The next thing we want to do is to copy view. So if I type in copy view, it's asking me what I want to copy. I'm going to say copy this thing please, hit enter, and now it's saying where do you want to put it? Well, I want to get rid of that and put it here and here and here and here and here, and then just hit enter because I'm done. Let's see, the next thing I want to do is I'm going to go to view 1 first, v space 1 space, and I'm going to type in ref. That's my reference point. Always a good idea to have a reference point. You're not going to get anything done without it. So really important here is we want to hold down the Alt key. So I'm going to go ahead and put my finger on the Alt key and just hold it there. And what I want to do is I want to click in the lower left corner of the first outline created. So it's going to be this one right here. And you want to let the O-snap take over and find the actual endpoint. So I'm going to go ahead and click, do a left click, and there's no active command going on at this moment, so we're good there. Okay, so got my reference points everywhere, and next thing I want to do is I want to create the first floor panels or walls, right? So I want to work in view 1. I'm going to go V, enter, 1, enter, and I'm going to type in panel trace. So PD is the shortcut command for panel trace, but you could also type it out. So let's see, panel trace. And the way we want to do it is via a rectangle. So I'm going to type in R. Notice that all these words are all capitalized, right? This panel trace command is asking you, hey, how would you like to make these panels? And if you type in R, because we want to use a rectangle, say R, and hit enter, now it's going to understand that we're going to define these panels via a rectangle. So holding the Alt key, I'm going to click up at this endpoint and click at this endpoint. And holding down Alt, put all these walls within that polyline, within that border, because our walls literally sit within that defined building footprint. So that's why we made that thing. Next thing we want to do is type in, or let's hit escape a couple times to just finish that panel trace command. Let's do LI, and what I'm going to do is just hover over these walls. Oh, I guess I can't do that, but if I go ahead and click on them, and I can, if I zoom in, I can see that I've successfully clicked and selected those panels. I can hit enter, and so LI allows me to change some of the properties of these specific panels. And so what I want to do is say panel usage. I'm going to set that to load bearing, which it already is set to. Floor type is going to be concrete because these are the first floor walls. So they're sitting on a concrete pad, right? My other options here are timber or steel. So concrete is the one that makes sense. My wall height, I want to make sure that it's at 8 feet. So 7 foot 10.5 is not going to cut it. 8 feet. My base level should be at 0 inches because this is the first floor. My stud spacing, I'm going to set that to 2 foot. So Let's go to stud spacing and say 2 feet, enter, and click code as. So now these walls are red. So as we move along through this exercise, we're going to notice that the load-bearing walls will turn red if they're set to load-bearing. Great. Let's also verify the noggin height. So I'm going to type in LI again, and I'm going to click all over those red walls. Let's go to noggin height, stud data, noggin heights, currently 4'13". So that's perfect. I'm going to set it there and just hit amend. I'm going to hit escape a couple times to make sure I'm out of the command. And now we're going to do panel trace one more time. And what we want to do is do the interior wall. So to do this, to trace this panel this time, instead of using the rectangle command, we're going to type in mid. And I want to find the midpoint of this panel, and I'm going to drag my cursor downwards, and the next thing I want to find is either the midpoint of this panel down below or a perpendicular point, because I want this to go straight up and butt up against that wall and create this perpendicularity. For some weird reason, the O snaps will reset as you're working in the command, so turn on perpendicular and go ahead and turn on mid if you can find it. Just always escapes me. Oh, it only wants one at a time. So I'm going to go with perpendicular because I definitely just want it to go straight up against this wall. And so now I've found the perpendicular point. I'm going to go ahead and click that. And now if you hover back and forth between the walls, it's going to do this fancy little dance because structure wants to know which way you want to lay this panel down. And this part doesn't really matter, so we're just going to choose one side. I'm going to move my cursor to the left and give it a click. I'm going to hit escape a couple times to just finish that command, type in LI. And let's go ahead and LI this panel here. Working? Oh, there we go. Let's hit enter. This time, this interior wall, I'm going to set it to be non-load bearing. What's going on here? So, panel usage, non-load bearing this time. And then click code as. And what you may or may not notice is now, instead of this amber color, this non-load bearing wall is this really bright yellow-green color. Alright, so the load bearing ones are red for your own reference, and the wall in the middle is really bright yellow. Okay, this is probably a good time to save, so let's go ahead and save. Alright, now what I want to do is type in LA to label these panels, and it's going to ask me to select panels to label or enter for global selection. I'm going to go ahead and create a window over all the walls and hit enter. And now it's asking me what number do I want to start with. I'm going to say 100, just to have this, naming convention that makes sense, right? 100 denotes the walls on the first floor, and probably will label the walls on the second floor 200. So that way when we go and print them, we'll know, oh, these are all on the bottom, and these ones that say 200 are going to be on the second floor. So hit enter, and you should have properly labeled walls. Notice that the load-bearing walls have an L, and this non-load-bearing wall has an N. So now what we can get onto is adding openings. So what we're going to do is type in UW for a user window, and I'm going to type in H for header height. I want to adjust the header height to be 6 foot 8 inches, which is typical. And my opening height for this window is going to be 4 feet, and my opening width is going to be 4 feet. Alright, so now what we want to do is the way we want to create these user windows is we want to define within this command how we want to lay these windows down. So let's go ahead and type in M for multiple, because we want to make more than one at one time. And if you click on the upper left corner of panel L100 to select your first point, click on the upper right corner of panel L100 for your second point. Type in 2 for quantity. It'll place 2 windows. So L100 is right here, and I'm going to click in this top left corner and top right corner. It's asking me for my quantity. I'm going to leave it set at 2 and hit enter. Okay, so now let's go ahead and make 2 more windows. I'm still in the window command, and I'm going to do 2 more windows on L102. So I'm going to click on this endpoint, click on this endpoint. You want to make sure that the endpoint that you're clicking on is not this endpoint or this endpoint, but the bottom right corner of this panel. We're going to keep that at 2, and now we've got 4 windows in our floor plan right now. So let's see, now we can do, let's do some doors. So the command for that would be, let's hit escape a couple times, and let's do UD for user door. Our opening height would be 6 foot 8 inches. Opening width, let's make that 36. And this time we're going to use the point offset, so type in PO. PO is capitalized here, and so is multiple, and so is center, the C and the M. So if you type in PO, we can do a point offset. And we're going to left click on the lower left corner of panel L101. It's going to be right here. And the direction we're going to go is this way. And the offset is going to be 5 feet. And there's our door. So let's do another door on N100. Same way. So I'm still in the user door command. It's asking me how I want to make the next door. PO is still selected, so I can just hit enter. Sorry, I guess I can. So user door, 6 foot 8 opening, 3 foot width, and PO. Let me just type in PO just to make sure. Okay, great. So now I can highlight this endpoint. I'm going to hover my cursor upwards in this direction. I'm going to left click, and my point offset distance will be 5 feet. So I'm going to hit enter. Now I've got another door there. And then the last door we want to make is going to be a garage door opening. So this user door, let's see, we're going to do it as we're going to choose C for center this time. So the start point would be here, and I'm going to pan up this way using the middle wheel button, and then click here. And there we go. That's a little small, so I'm going to escape a couple times and undo that. Okay, great. So I'm just going to start the command over again. UD, opening height 6 feet, the width is 12 feet. And I'm going to choose C for center. And I'm going to click here, and I'm going to click here, and structure will find the center of those 2 points and put a big 12-foot opening there. Alright, so now what we want to do is hit save. Oops, I'm going to hit escape a couple times and hit save. Okay, just do a quick save. And let's do A3D. I'm using the middle wheel button. If I just click and hold and drag it around, the middle wheel button will do what is called a pan. If I hold down the shift while I'm panning, if I hold down shift and start panning, I can actually do what's called an orbit. So this is how I'm navigating around the 3D viewport. So everything's looking good. Got 4 windows, 2 regular doors, and a garage door. Okay, so let's go back to layouts. And I am gonna hit escape a couple times, and what I want to do now is create support lines. So if I type in CSL, okay, I can window select all of these walls. So I'm going to click right over here in this corner, and I'm going to click way over here in this corner. I want to make sure to encapsulate all the walls, and I'm going to hit enter. Now it's asking me where I want to copy, where I want to put these support lines, and I want to do a left click here in view 2, and I can zoom in to double check to make sure this is view 2. Let's see, where does it say view name? It's hard to read because of Oporto's crazy file naming scheme, but this is view 2 of 6 right here under view name. So I can go ahead and left click right there in view 2 and hit escape a couple times. If I zoom into view 2, what it's done is it's created support lines to represent where the walls are occurring within the building footprint. This will help me create the second story floor. Okay, so now what we want to do is let's save. We're going to create some floor joists now. So I'm going to do V space 2 space, and just so I know I'm in view 2, I'm going to type in JD to create the floor layout, and I'm going to select the polyline outline and press enter. So let's zoom in. Let's click on that polyline and hit enter. You want to make sure that ortho is on. This is ortho right here. If it's highlighted yellow, it means it's on. If it's not highlighted yellow, click right there, so that way you can turn ortho on. And we're going to move our cursor to the upper left corner of the outline, which is right here. And then you're going to left click and indicate the direction of the joist. So if I click here, and now what you're seeing on the screen is this is Structure's way of asking me which way I want my joists to run, and I want them running this way, right? This is the shorter span, right? If I did it this way, that's a longer span, and that just doesn't make much sense. So I'm going to go down this way, and I'm going to left click there, and you should get something like this. Okay, so these should all be sitting directly above the original polyline or the building footprint that we had put in each view. This is the support line below, and it's sticking out inwards towards the center of the building. So this is all looking good. Except I've got a double right here. I don't really need a double. So what you could do is you could actually delete that if you wanted to. Or you could just bring it back. I don't think it'll hurt to have double. Let's see. Oh, I see what it's doing. Wow, that's kind of cool. Okay, so I'm going to investigate a little bit. I'm going to type in JSet to see what I might have on that's incorrect. So I'm going to go back in my PDF, go back to JSet. I want to check out my joist settings. So for JSet, bearer method should be set to blocking. So that's probably what we're seeing. This is probably a result of bearers inline. So what I'm going to do is undo. This is incorrect as far as what we have in this tutorial, so I'm going to undo just far enough so that way my floor is gone. I'm going to type in JSet, and for bearer's method we need blocking and blocking. Okay, I'm going to save that. Now I'm going to type in JD. I'm going to select this polyline, hit enter. I'm going to left click on that endpoint there, direction of joists. I want them to go straight up and down this way. And there we go, much better. So this is what's known as the blocking method for bearers and internal bearers. So that's what you get. You get these smaller pieces instead of a huge long piece. So that's looking good. Okay, so let me go back to my PDF and scroll down, scroll down, scroll down. Okay, so at any point in time as you're going through this model, hitting A3D a couple times is good for you to preview everything to make sure that everything's in the right place. So if I type in A3D, that's going to delete the previous 3D model that I had looked at, and then I can type it in again, or since it was the last command, I could just hit enter. By hitting enter without typing anything, it's just going to repeat the last command. And there we go. This is looking perfect. I've got 5 walls on the first floor. I've got a floor directly above and on top of those walls. Everything's looking really good. So if this floor was on the ground, I would know that I set the reduce level at the wrong height, because the floor on the ground is not going to be a FrameCAD thing. That's going to be like a concrete pad. So it's looking good. So back to layouts. Let's create the second floor now. So I'm going to type in V space 3 space and utilize view number 3. And again, the numbering scheme here in structure is 1 is this bottom left one here, 2 is directly above it, and then you go diagonal, 3, 4, 5, and 6. But I like to just hit V space 3 space. That way I don't even have to worry about what the numbering scheme is. It's just going to take me to view 3. So in view 3, we're going to type in PD for panel trace. We're going to use R for rectangle. And we're going to hold down the Alt key. And I'm going to hover over this corner until I find the endpoint. And hover over this corner, still holding down Alt. And boom, I'm going to put those 4 walls in place. Okay, I'm going to hit escape a couple times. I'm going to type in LI. I'm going to hover over, I'm going to select all these walls just like that and hit enter. These walls are going to be load bearing because they will be bearing the load of the roof or trusses. So yes, they are load bearing. The floor type this time is steel because we just made our steel floor. so we can tell this program that. Wall height is going to stay at 8 feet. Base level. The base level is similar to the reduced level. So what we want to say is the base level is 8 foot 11.5 inches. So that way structures understands to put these 4 walls on top of the floor, which is at 8 foot 11.5. And stud spacing, let's make sure that says 2 feet. That's perfect. And let's click Code As. Walls turn red. Those are load bearing. Let's do LI again and hover over these walls and double check the noggin height. Let's go to noggin height. So 4 foot 13/16. That's perfect. It's recommended that if your walls are taller than 8 feet, you go ahead and add a second set of noggin heights at 8 foot 13/16. So we're going to leave it as that. Let's go ahead and label these. So I'm going to hit escape a couple times, hit LA. I'm going to make sure to click and select all these walls, and the labeling method is going to be 200. I'm going to label them with 200 as a starting point. I'm going to hit save. So we got L200, 203 is right here, 202, and 201. So when I go to print these out, I know that since they're 200s, they're going on the second floor. So now what we're going to do is put in some more windows, so that way we can look out at the view in our 2-story home. So UW, let's type in H for header height. Make sure that it's at 6'8". It is, because it remembers the dimensions I used last time. Our height is going to be 4 feet. Perfect. Width 4 feet. Perfect. I'm just hitting enter. And we're going to type in M for multiple. I'm going to go right over here. I'm going to find that point, and I'm going to go right over here, and I'm going to click on that point. And it's asking me the quantity that I want. I'm going to say 2, hit enter, and there we go. So I'm still in that command. I'm going to just go ahead and do it all over again. Do it here to there. Quantity of 2. There you go. Let's do it here to here. Quantity of 2. All right. I guess this wall doesn't get any windows. It's definitely not getting doors. So let's hit escape a couple times. Let's do a nice quick save and type in A3D once. Hit space one more time. Remember, you can hit space, enter, or right click, but that'll repeat the A3D command. And check out your progress. Everything's looking great. Alright, so let's go back to layouts. This time we're going to create some more support lines. So I'm going to type in CSL, and I'm going to create a nice big window to show where all these walls are. I'm going to hit enter. I want to be in view 4, so again 1, 2, 3, 4, and I'm going to click within that view. And if I look closely, it transferred some support lines onto this sheet. Hit escape a couple times. Hit save. So now we can do the roof. First thing we want to do is create the roof overhang. So to do that, we're going to type in O for offset, and the overhang distance is going to be 12 inches. And I want to offset our building footprint, and it's giving me this line. So whenever you see this line, it's always structure's way of asking you, hey, which way do you want to go? So I want to offset this building footprint 12 inches this way, because roofs overhang that way. They're not going to go inwards. So I'm going to click out here, and now I've got a nice 12-inch offset. I can hit escape a couple times. So now what we want to do is type in RL. So RL, this is going to allow us to turn some of these lines into roof lines. So if you left click the outer offset line and hit enter, it's going to turn a nice cyan color. And hit escape a couple times and type in TD. So we did PD for panel trace, we did JD for joist, and now we're doing TD for trusses. So the way I'm going to do this is left click on the lower left corner of the inside boundary, and left click on the lower left corner of the inside boundary, lower left. So if I click right here, that'll be my first click. I already clicked it. There's that dash line asking you, hey, which way are we going? Now we're going to go to the upper left corner, right over here. And then now we're going to give it a direction again, and we basically want to tell it to go this way. So move the cursor to the next, click on the upper right corner of the inside boundary line to indicate the area you want the trusses to cover. So we want to define the maximum extents of the trusses, and you can click on this top right corner. In the command line, you're going to see different roof style options, and then the drawing, you should see a star over the left side of the roof. I'm not seeing my star right now, but I'm sure it's there somewhere in spirit. We want to do a gable, so G for gable. Okay, now the star is moved over here. This part of the roof is a hip, so we type in H for hip. Okay. So that's looking pretty good. Let's type in L8 so we can label them. And I'm going to right click on the mouse to globally select all of the trusses. Okay, now they're all labeled. I'm going to do a quick save. And let's type in A3D a couple times. That's what your model should look like. Okay. So, and also, if you double click on the middle wheel button in 3D, what it'll do is center your 3D model within the center of this viewport. So if you were to zoom out like this using the scroll wheel, just double click on that scroll wheel and it'll zoom you right into your model. Let's go back to layouts now. So we're here in view 4. I'm going to type in TTD. In the past we've used PPD for panels. TTD is the one we want to use for trusses. And so if you expand this dialog box a little bit and expand this so you can clearly read all the item names, I've got all my trusses sitting right here as a list. And as I click through them, you can actually view each truss. This is what FrameCAD will print for you. If you look at them, it shows you the label that we gave them. It shows you the type of truss we've created, and it also shows you a quantity number, and additionally, for some of them, it'll show whether or not it failed. It doesn't show passing for all the other ones, but if you click on this one, you'll notice that the text down here, which shows the engineering status, this is all red. If I go to one that didn't fail, the text is all green. So we're all good to go on those. Notice that the engineering status is always 100% or less than 100% if it's a passing grade. For the failing one, it's above 100%. So this will be an area we need to fix. So what we want to do now is select all of the trusses and click on to CAD. And so I'm going to give it a moment. And so next to our Layouts tab, there's going to be a new tab here called Truss Point 1. And this is a layout of each and every single truss. Okay. We can go through and modify these a little bit here. But what we want to do is we want to look for the one with that failed, and that's going to be this one right here. And we're going to attempt to use a few techniques to help it pass its engineering status. So I'm going to type in BM for truss box. I'm going to hold down the Alt key and left click on the upper left corner of the chord H3. So find chord H3. Holding down Alt, I'm going to click on this upper left corner. And I'm going to click on the upper right corner of H3. Alright. So once you make that kind of modification that moves you towards fixing the engineering of this specific truss, once you make any change to this truss here in this view, the engineering status will change to unknown. And that's because as we continue to reinforce it in certain ways, it's not going to update the engineering status until we code it, once we're done with the repairs that we're doing right now. So let's type in BM one more time, and we're going to hold down the Alt key, and we're going to click on the lower left corner of the bottom chord B1 and the lower right corner of bottom chord B1. So I'm going to zoom in. B1 is this bottom piece here. Okay. And holding down Alt, clicking this endpoint, zooming out with the scroll wheel, and then clicking right there. And as you can see, it added something to it, and what it's done is it's actually doubled up on that, and you can see the extra little piece here and there. Okay. Again, the engineering status is unknown. So now what we're going to do is go to T3. We're going to do the same thing. So I'm not even going to type in BM. I'm just going to hit the space bar, and I'm going to hold down Alt, click on this left corner, click on this right corner, watch it do its thing. You can hit space again to repeat that command, hold down Alt, do one here, and I really want to make sure I get endpoints and not necessarily just a near point. Alright, that one's all doubled up now too. Hit escape a couple times. So, we've heavily reinforced the top chord, bottom chord, and the sides. So what we want to do is type in dash TTD. Okay, make sure you put that little dash in there. Hit enter. Okay, zoom out, and you'll notice that engineering status is now set to 53%. So we're good now. So type in TTD, click on this one, and say update. Okay, perfect. Let's go back to layouts. Let's type in A3D a few times and just look at that. That's kind of cool. So what we want to do now is we want to let's go to View, and let's go to Visual Styles, and let's go to Realistic. So we're not in wireframe mode anymore. And so here in Realistic, you'll notice that the only items that look somewhat realistic are the trusses. The trusses were the ones that we actually sent to CAD, right? They were actual things that were CAD'd out, if you want to say. But the walls still haven't been done, right? They're still kind of in a more conceptual mode right now, but we'll get to those very soon. This is so cool. All right, so let's keep going. Oh, also, check out that previously failed beam. Look how it's doubled it up. You see, so it put another stick right here on the side, and that's going to help reinforce it. Up here, on here, and down there. Alright, save, please save. Alright, let's go back to the Layouts tab, and let's get more detail going for our panels. So let's type in PPD. Oh, excuse me. I want to go to View 3, so V space 3 space. These are my second floor walls. PPD. Alright. And when you're in PPD or in TTD and JJD, you get a lot of information about all these pieces. You get a quick preview of the elevation and a bunch of information concerning weight, which will help you figure out cost before you even start building, and of course engineering status. So let's go through and double check and make sure nothing failed. I can tell nothing failed because it would have had the word failed in parentheses on the right side of these panels. Also, as I scroll through by clicking each one, the status is passing for all of them. So we're going to hit select all and to CAD. Okay, let's do A3D a few times and see how our model's updated. So it's looking super real now. And also, when we did to CAD, we have this new tab now, Panel 1. And we can go through and double check, make sure everything looks okay. Make sure our headers are at 6'8". Make sure the windows are the right size. Sill heights are correct. Top plates in the right place. There's our noggins at 4 foot 13/16. Everything's looking really clean. Cool. Save. Save. So let's go back to layouts. Let's do V space 2 space. Actually, that one's all done already. So let's go V space 1 space. And yeah, that's looking all really good. Let's do A3D again. I just want to check something. Okay, yeah. So let's do PPD. Okay, everything's all passing. These are my 100s. Alright, they all look good. Select all to CAD. Got a new sheet, panel 0.2. Let's do A3D again. Voila, that's all looking really clean. Alright, save. Let's go to layouts. Let's go V space 2 space. I want to go to view 2. Let's type in JJD. And again, I would suggest that you expand this dialog box so that way you can expand this panel on the side. What we want to make sure to do is check and see if anything failed. And looks like we've got this one that's failed, J1, and there are 10 of them that have failed, so that's not good. So go ahead and if you click on the engineering tab, you can see the top chord is red, and that's where the truss is failing. So it's this one right here. It's above that 100% threshold that we like. Right, you can actually zoom in this thing and pan around it, but you can see engineering results. It's all color coded, and it's the top chord that's really having the issue. So that's how you can identify which part of the truss you need to go and fix. Seems to all be in the center, but that's fine. Let's select all, and return to the fabrication tab, select all, to CAD. We have a new tab now called 4.1. Let's go and find that view showing the failed trusses. So let's zoom out. We're looking for red. Here it is. So we're going to start to fix this one. Let's type in BM. Okay. And we're going to click the upper left corner of this top chord. There's a few endpoints here. Oh, it's regen now. There's a few endpoints here. I want to make sure to hit that top one up there. Let's zoom out and do this one here as well. Okay, so boom, that's reinforced now. Engineering status is unknown. So hit escape a few times, type in -JJD, and it's reevaluated and understands now this is got a passing status. So we were able to fix that top chord. Type in JJD, hit enter, and expand this panel. Great, it's passed, it's not failed. Click on update. That's looking good. Let's do A3D once and a second time, and check that out. There are your joists. Everything's all framed out now. It's looking nice. So now we're going to work on adding bracing. So let's go back to layouts. Let's go to view 3. So V space 3 space. Now we're in view 3. We're going to type in PCB for panel wind. PCB. The lateral bracing calculation dialog box appears with text shown in red. I like to expand this a little bit because it doesn't usually give me enough room to read everything. Okay, so we're looking at the wind forces in the X direction. It says 1.5. Wind forces in the Y direction. It says 2.0. And I don't think you can change this. This is actually just showing live data. So these are not optional things that we can make amendments to. Shortage X 0.1 KIP. Mine says 1.1. And shortage Y KIP 1.7. under bracing options, we want to make sure the boxes for external sheath one side and internal sheath one side are checked. External sheath one side, check. Internal sheath one side, check. And you can start to see it's updating some of this data here. Click on the insert button in the lower left corner. And in the command line, the default will be K-brace. So we had also set that up in our P-set, that our panel bracing option would be the K-brace variety. Let's move our cursor to the panel 201. It's going to be this left one here. And we're going to add braces. So bottom center window view, and left click in the second space between the studs in the lower left of the panel. So lower left. So if I just click right there once, you'll see an X. We're going to add braces in the next two spaces moving up, so a total 3 at the lower left corner. So if I zoom out a little bit, I want to get my cursor lined up in between this stud and this stud, and click. Same thing above this, in between these two studs, and click. And we're going to add braces in the two spaces in the upper left corner of panel 201. So let's zoom out. Upper left hand corner is this one and this one. So we've got a total of 5 right now. We're going to add a brace in the left and right corners of panel 220. So, actually L220. That must mean that's probably 202. Sorry, a little typo there. So add a brace in the left and right corners of panel 220. I'm sorry, 202. So left side, right side. Add a brace in the top and bottom corner of 203. This is 203, so bottom and top. And add a brace in the left and right corners of panel 202. Okay, I see what happened. Number 8 in the instructions should have said 200. And number 10 should say L202. So, doesn't really matter. What we want to do is we want to put 2 bracing pieces here, 3 on the bottom portion of L201. I want to put 1 in each corner of the remaining panels. Let's hit enter. Hit escape a couple times to make sure you're out of the command. Now let's type in PCB, and we don't see red anymore. So shortage X 0, shortage Y 0. So by further bracing these panels, we're now passing for our lateral bracing. So that's all looking good. Let's insert. Let's go to the first floor. So V space 1 space. I'm sorry. I'm going to hit escape a couple times. V space 1 space. PCB. Red. All red. So let's go to bracing options and make sure external sheath one side, internal sheath one side are set. Okay. In the structure tab, let's go to P-set. So just type in P-set. Hit escape a couple times and hit P-set. Brace panel information. Brace type. This time we're going to do double straps instead of the K-brace. And the stud bays or strap angle is going to be 45. It already automatically sets it to 45. Click Save. And then let's type in PCB. Okay, so now we're going to insert our bracing. Let's see, where do we want to put them? So if you look at the diagram on page 19, it's labeling where we're putting that double straps. So let's go through and do that. It's going to be the same thing as the K-bracing that we added. It's between studs, so let's click right here. And as you can see, it just went ahead and did it all along this whole part of this panel. And let's do it. Let's do it here. I probably don't have enough space to do it there, so I think one goes here. Does it not? Oh, there we go. I'm just clicking in the wrong area. No? Okay. Can we put one there? Nope. Can we put one in the middle? Nope. Well, it says here in our tutorial that we should check PCB until the text appears in black. So let's hit escape a couple times, do PCB. Okay, so the text is all red. So let's go ahead and click insert. Alright, let's see where else we can add some. Here. There we go. I put one here. Perfect. I put one here. Alright. There. Now, can't put one in an opening. Can't put one there. I put one over here somewhere. Alright, there we go. I'm just clicking in between studs. Okay, that one's still like that. So I hit enter. Let's do PCB. Oof. Still have all this red text. But these numbers are going down, which is good. Let's keep going. Maybe I can put some in here. Will that help? I don't think it'll help. These are non-load bearing. Oh. Okay, let's see if that helps. PCB. Oh, perfect. Alright, I'm done. Alright, so now that everything's looking good, I can hit close. I'm not going to click insert. I'm no longer seeking to add more bracing. Right click on panel point 1. This is panel point 1 right here. And we're going to hit delete. And actually, because of the way I did this tutorial, panel point 1 is actually, these are my second floor walls. So it's actually, for me, in this case, and probably for you, if you're following along, panel point 2, right? It's the 100s, right? The walls that are labeled 100. So I'm going to right click this one. I'm going to just totally delete it. I'm going to hit OK. Totally fine. Go back to layouts. Type in PPD. Everything's passing. Select all. To CAD. And now I have a new one. You can actually rename these if that helps you. I'm going to say second floor walls. This one is floor. Oh shoot, that's not how you spell floor. If you just double click on the tab, it will allow you to change the name. Whoops, these ones are the second floor walls. Dang it, these are first floor walls. These are second floor walls. Trusses. Perfect. That'll be easier for me to understand. And I think I could probably move them around. No, I guess I can't. let's see, page setup manager, explore layouts. Oh, move left. Okay, great. I think I'm going to move this one left 1, 2, 3 times. I'm going to move second floor walls left 1 time, and floor I'm going to move left 1 time. That's just me being nitpicky. I just want to see first floor walls, then the second floor walls, then the floor, then the trusses. Just makes more sense to me that way. Oh, let's hit save. Alright, let's do A3D a couple times and check out the cool house that we've made. Yeah, that's looking great. Oh, okay, this is interesting. So to finish off this exercise, we're here in the model view. If you go to the view tab, which is right here, in the ribbon at the top of the screen, locate the view cube, that's right here. Click on the down arrow and select top. Oops, I meant top. There we go. I'm in top view right now. In the model tab, top view in lower structure tab. So if I go to the structure tab, we're going to go to the section. Where is section? Structure viewing, section line. It's going to give us an error message. AEC units mismatch error. Press OK. AEC units. Let's press OK. And so what we're going to do now is we're going to create a section. So let's make sure that ortho is on. This one right here, it should be highlighted yellow. And I am going to go ahead and create 2 sections. So to do that, I am going to click to the left side over here. So I've just made a left click. And because ortho is on, I'm constrained to only draw straight lines at this moment, which is really good because I'm going to cut a section. The next point is going to be right here on the right side somewhere. And now this little line is asking me which way do I want to cut my section. So a section is a type of drawing that we use in architecture to cut through our building, slice it open as if it were a cake. So we're slicing it open, and the direction we want to look at it is this way. So let's go ahead and click on this one, and let's hit enter. Okay. Now we have this big giant double X. Okay. And if you just click somewhere here on the canvas, what it just did is it actually gave me a section drawing. I can move this around, but this is what a 2-story house looks like when you slice through it, where I just sliced through it. So this is called the section drawing. So let's do another one and click there, and we're going to click above, go straight down, and click somewhere below, and click towards the right. Okay, just hit enter, and I'm going to click somewhere over here off to the side, and there we go. This is another section cut, cutting through the building, but now the opposite way. Okay, so I can actually select all that, hit M for move. What I kind of want to do is I want to line them up. So I'm just going to find the bottom. Okay. And now highlight it again and move it just a little bit off so that way they're just aligned. Now this issue is kind of bothering me. These symbols are just like way too huge. And I am unsure how to fix that. I know how to do it in Revit. It's not the biggest issue if we leave it like that, but gee, this is really ugly. View Manager. It's just an annotation scaling issue, but it's not really the end of the world. This thing is kind of a clunky software. Whatever. I'm just going to leave it like that. Alright, cool. So that's basically it. Let's hit A3D a couple times. Oh, that's right. We're already in 3D. So let's click here and let's look at it as an aerial from the right front. And I'm going to hold down Shift, click and drag the middle wheel button. And I want to make sure that you guys were able to do this, so please screenshot this in any sort of way that you can. I think natively Aporto has a screenshot or snapshot component to it. I think if you click this one here, let's see what that does. Save a new snapshot or restore a previous one. Let's save. Save your work and close applications. Your session will temporarily disconnect while saving a snap. This may take up to 2 hours. Jeez. Let's just cancel that and just close that. That sounds ridiculous. So the way we can do this is if you click Start, let's see if they have a snipping tool. Yeah, snipping tool is still here. Alright, so snipping tool is a very old Windows application, so it just does a screenshot for you and saves it as a JPEG. So the way we're going to do it is if you click on this drop down arrow next to mode, let's do a window snip, and let's go ahead and click on new. Sorry, try again. New. Now we click here, and that's it. Didn't take 2 hours. Took like 2 seconds. Okay, so all it is was it took a snapshot of the window that we're working in. Right, so what we want to do now is go File, Save As. I would navigate to the desktop, find your folder that you've made, find this class, and let's give this a file name and call it 2-story house. Put your initials on it and hit save, and then upload this to Canvas so you can get a grade. Awesome. Save your work. So I'm going to close that down. I'm going to go ahead and close structure down. I'm going to hit yes and no to this drawing 1. And you're all done with the 2-story house for now. And good job. I'll see you guys soon.